will be given by LONGi. We are happy to have with us Jason Yan, who is the Senior Product Marketing Manager of LONGi, and he will talk about the value proposition of LONGi's M10 based bifacial PERC modules for larger scale applications. Jason, good to see you. The floor is yours.
Hello, everyone. This is Jason Yan from LONGi, and thanks, Michael, for a kind introduction. So today's my topic is about the value proposition of 182 millimeters M10 based on bifacial PERC models in large solar applications. So basically, my presentation will include 4 parts. First one is I will introduce actually the technology evolution of PV model. And secondly, I will give the introduction of the design methodology of LONGi's HAMR 5. And then thirdly, I will introduce the reliability and the system value advantages of HAMR 5. And lastly, I will introduce the LONGi's Intersolar product review. So when we look at the PV product development history, we can find that the technology reducing the LCOE will gradually wins. So for example, in terms of cell roadmap, the mono PERC will finally replace the back service field cell. And in terms of model roadmap, the half-cut plus MBB becomes the mainstream model technology. And also the bifacial model dominated the utility power plants. And then when we look at the size development, actually it is based on the reduced manufacturing cost of the larger wafer size. So after 158.75 millimeters, industry began to think more about the terminal requirement with considering each factors. And one example is that actually for the bifacial PERC model. So basically, LONGi launched the bifacial and the dual glass model based on the bifacial PERC cell in May 2017, which is well ahead of competition. So after that, LONGi verified the bifacial gain and reliability of bifacial model by a third party and customer pilot projects over the world. So has continued to promote the bifacial model to increase its global market share. Actually, I think this year the market share maybe it goes up to about 50%. So in the next few years, the bifacial model market share will go up very quickly. And another example is about the large-scale application of half-cut technology. So we all know the half-cut technology have the operating current of the cells and reduce the internal heat loss of the model, which it will reduce the hotspot temperature and leaving room for a moderate increase in cell size in the future. Basically, a lot of studies show that the half-cut technology can also improve the power generation performance when there are shadows, uneven lights, and high irradiation. So we can see in the 3 figure below, both all of the from half CSP and IC studies showed that when the irradiation is higher, actually the critical value is about 400 or 500. The energy yield of the half-cut cells will be higher than the full cell models. And then we go to the second part of this presentation, which is about the design methodology of the HAMR 5. So basically, based on the new building capacity and the entire industry chain, M10 wafer size was introduced to realize the standardization of manufacturing system and application system. And also it can realize the reduction of model manufacturing cost and the system cost. So based on the thorough analysis on the production feasibility cost and model reliability, system compatibility, and model transportation and manual handling. So we found that the optimum model dimension is deduced by the corresponding wafer size, which is about 182 millimeters. And we think the future increase the model size cannot bring value and manufacturing of system size. However, it will bring increase the risk of reliability. So that's the idea. That's why we actually we want to unify the size for the M10 182 millimeters product. Actually, in last year, top 3 manufacturers, I think LONGi, Jinko, and J, has an announcement that we have a unified size for the M10 product. So the idea of this proposal is that we think it's beneficial for the reliable industrial chain. We can see if the model size is locked down, that means both the glass or EV or POE will have the same size. So that's very beneficial for the stable supplier. And in another point, if we supply the unified size product, that means our downstream customer can easily construct the power plant. So for example, if the customer want to switch to another brand product, and then that does not need to change their design of the power plant. And also they did not need to change their record design. So that's also beneficial for the, I think, EPC and downstream EPC and installers. So that's the idea. We think the unified size for the M10 product is beneficial for the whole industry chain. We are focused on improve the cell efficiency. So instead of keeping change the size of the model, that will cause I think confusion of a customer. And when we see the HAMR 5, so we can see 182 wafer has high manufacturing yield. So LONGi's 182 PERC cell actually has achieved a benchmark factory efficiency about 23.8%. And the efficiency is expected to reach about 24% by the end of this year. And also in the second half of this year, and the main power of HAMR 5, so based on the standard size will be 550 watts with an efficiency of 21.3%. And also when we look at the market share of 182 models, we can see it will quickly exceed half of the market share. So with the reasonable design, the 182 models launched actually in 2020 have a significantly higher market share. And also last year, the global shipment of 182 model is about 48.5 gigawatts. And I think it's expected to achieve a market share of more than 50% in 2022. And also third-party institutions have adjusted the market share expectations based on the equipment manufacturing capabilities. And in fact, in the second half of 2021, a large number of 210 cell and wafer production capacity transformed to 182 products. So that's why in the next few years, the market share of 182 will be higher than 50%. And a third part is I will introduce the reliability and the system value advantage of HAMR 5. So basically in terms of the package, we all know the landscape package is common and mature. So the 182 models use the landscape package, so which can meet the convenient loading and unloading of the container. And also in terms of the model mechanical loading performance, we can see when we use the same 2+2 millimeters glass construction, model size power cannot continue to increase without compromising reliability. We can see when the model weight increase from the 1.13 meters to 1.3 meters, the deformation will increase about 40 to 60%. Which will result in the higher hardware degradation and more micro cracks. And in terms of wind tunnel test results, we can see the strength of HAMR 5 is about 30% higher than the oversized model. And in this case, the HAMR 5 can easily pass the 60 millimeters per second wind tunnel test because of optimized frame design and optimal size. And in terms of the anti-hail impact performance, we can find that with the significant increase of motor weight, so its tempered property will decrease. So actually, the tempered property of HAMR 5 will be 10% higher than the oversized model. So that means LONGi's HAMR 5 model power degradation is less than 0.5% and 35 millimeters hail impact test. And we also test 3 other oversized models, as they all failed at the 35 millimeters hail impact test. Both front and back glass were both broken. And recently, we did some study on the thermal runaway evaluation of the junction box diode. So basically, what is thermal runaway? It's just like when the cover on the model that causes a hot spot, and when it is removed, the diode changes from on to off, and the thermal runaway will occur. The mechanism is that the increase of the forward current and the reverse voltage will increase the risk of diode thermal runaway. In the figure below, so we test 3 different junction box. So LONGi's 25 amp junction box is a red line, and we can see the small circle is the measured value, and the fit line is a red curve. We can see when the forward current and the reverse voltage of the model is below the red line, that means it's in the safe area. And if the parameters is higher than the fit line, which about the two curve of 30 amp junction box, that means the thermal runaway will occur. So LONGi's 25 amp junction box actually can meet the requirements of the bifacial model. And when we go to the system value analysis, in terms of labor cost, we can see too wide of the model will cause inconvenience to the installation, and too large of the model will also cause difficulty to model installation. And in terms of tracker cost, we can see because of the limited length of trackers, actually for 1P tracker, so the limited length is about 100 meters. That means for 182 72 cells model, we can install 3 strings. That means the total power is about 45 kilowatts. And for the 210 60 cells model, it can only install 2 strings. So the total power is 40 kilowatts. So that means the total power by 182 is about 10% higher than the 210. That means the track cost is lower and the cost per watt is higher. And in terms of 2P tracker, also the total power is about the same, which is about 60 kilowatts. However, there is a string of model will be arranged on the separate side, so it will lead into the power loss due to the obvious mismatch for the 210 model. And in terms of electric cost, we can see if 4 millimeter square cables are used, the cost of 182 is already at the optimal value. In the below figure and in the table, we can see if the working current is about 40 amps, so the total cost is minimum for the model. And we also did some both comparison for 2 different models. We can see there is no significant difference in both costs between HAMR 5 and the 655 watts model with the same efficiency under reasonable boundary condition. So actually, we did 2 different scenario analysis for cable, both of 4 square millimeters and 6 square millimeters. So actually, for the 655 watts model with 4 millimeters cables, it will save the 0.092 cents per watts of BOS cost, but also increase the cable cost by 0.24%. And so we can see BOS cost savings with increased motor size, with larger format models have reached a plateau recently, and BOS cost levels off with the larger motor size and higher power resulting in efficiency improvement. We can see previously from M2 to M6 and M10, the BOS cost reduced significantly. However, when it goes to G12, so then it reached a plateau. And we did some analysis on the power generation performance in demo project. So we can see the comparison of power generation shows that 1 2 models under the high current, actually, which is about the 80.5 model, showed the similar results of the half cell versus full cell model, which means the 182 model with the lower internal loss will have more power generation when the irradiation is high. Basically, in the right-hand figure, we can see the critical irradiation is about 5 watts per square meters. And so when the irradiation is higher than 500, the yield gain is positive. That means with the lower internal loss, the 182 model will have the higher energy yield. So the results show that actually the design direction of the PV models should still be to improve efficiency and to reduce the loss of instead of improving current. And last part, I think I will give a quick introduction of the LONGi's Intersolar product overview. So first one, I think we showed the HIMO 5 M54 cells using industry standard M10 wafer with the standardized model format. Basically, we have two kind of products. One is the standard size, a standard one, and another one is most famous, I think, in Europe and American market. It's all black one. So both of these two products is the length is about 70 and 22 millimeters, and the width is about 1134 millimeters. So and with and the model weight is about 21.5 kilograms. And another, I think, product is about the LONGi Roof. So basically, it's a BIPV product. Actually, so LONGi Roof has 6 main advantages. One is the higher external resistance. The surface mechanical loading can reach about 5,400 Pascal. And secondly, we have the strong wind resistance. Actually, it can have the capacity over 10,000 Pascal. And also because of a unique design, so it have a higher heat radiation. So rapid heat radiation able to increase about yield about 4%. And fourthly, we have the higher waterproof capacity, and then the higher efficiency and the higher reliability. And another product is about LONGi's Bright, so which is about the modern architecture aesthetics. So we have 4 advantages. One is the customer design of architecture aesthetics. Second one is the efficient power generation. And thirdly is the higher reliability. And lastly is we have the multiple color options. Basically, we have actually 16 colors which customer can select for this product. So last conclusion, we think the PV product and technology should be based on the LCOE and consider comprehensive cost, energy yield, and reliability. And the model size change should consider reliability and feasibility, and system value analysis should be done in combination with application scenarios. So we think 182 model is the optimal size for utility scale power plants. Actually, PERC can, as I mentioned before, PERC can achieve a cell efficiency of more than 24%, and the mass production efficiency target of the next generation cell, we think should be more than 25%. It will be competitive. That's all. Thank you, guys.
Thanks, Jason. Great overview. Just one quick question, and maybe you can stay if there are a few more questions in the chat. So everyone, please ask your questions in the chat. So I think it was really interesting also that you showed all these BIPV products. Are they available worldwide? And what kind of and as of when are they available? And yeah, how big do you think will be the demand for that product this year and the next? So if you look at the curtain walls and the industrial commercial BIPV modules.
Let me answer you this way. So basically for the BIPV, both of LONGi's Roof and LONGi's Bright product, actually we have a lot of case study in China. This year we have installed many cases. So actually we think it's a trend for the BIPV product. So until now, actually we plan to actually sold it globally. So the plan is not determined. I think the trend is we want to sell it globally, maybe in Europe and in some Western countries and American, some area like that. Yeah, basically because you know the BIP product has advantage since it is frameless and it does not use the racker, so it can save the cost of the racker and frame, and also the design can avoid the dust, so it can increase the energy yield. So we think it's a big trend for the global market.
And in China, this product is available, you said. How big are the volumes this year already for these products?
Actually, we have actually several cases. So the BIPV product is normally installed on the factory rooftop with the steel rooftop. So basically, it will depend on the size of factory. It's mainly, so normally it's about 1 megawatt to 10 megawatts the size, and the total size of the BIP product actually in China, I think is about 100 megawatts, something like that. Yeah.
Okay, thanks. Okay, if there's any questions, please put it in the chat. Thanks a lot, Jason. Very interesting.
Okay. Yeah, thanks.
Let's continue. So with the next speaker. So we're happy.